I got the sign. Warm welcome, everyone. We will do it in English for the sake of many people who are joining online and want to understand it in English. We're all Swedish speaking though, so when we go to the question session, you will be welcome to ask us questions in any language, either Swedish or English, sorry. And the topic for today's seminar is AI for safety critical systems. Why we have this topic? First of all, obviously we've seen the advances of artificial intelligence. It's a very, very promising technology. We've all seen ChatGPT. It's mind-blowing. We've all seen the advances of deep learning when it came to natural language processing. We've seen artificial intelligence playing Jeopardy, playing chess, and the advances are amazing. The question is, how far can we go, and how far can we trust the algorithms when you put it in a safety-critical context? Which is why we'll have this discussion today, because this panel here, and soon I will tell you who they are, this panel here will describe their safety-critical industries and safety-critical use cases. And we discuss how far can we go and how far we can rely on artificial intelligence technologies. The speakers of today, so myself, I'm not the speaker, I will just be the moderator today. And the speakers today are Helena Börjesson, who is Chief Technology Officer at Medela, which is a company, it's a Swiss company, right, Helena? And you're based in Stockholm. Thomas Olsson, founding engineer at Einride. We have Caroline Jakobsson, who is at Ericsson, system management lead at Global AI Accelerator. And Shiva Sander Tavallaey, who is the AI lead at APB in Sweden, Västerås. And we start here with short pitches from each of these speakers who will present the context of their industries. We should have had another speaker, I should say, from Saab, representing aeronautics use cases, but he unfortunately couldn't join, he's ill. So here we go, let's start. And the first speaker out is Helena.
Helena. Hi everyone, thanks for taking the time and joining us today on this topic. Today I'm here representing the medtech industry. So even if I'm in a specific company, Helena just mentioned, and bear with me, I've just been 7 days with Medela so far, so the company specific stuff will be difficult. But I have a longer background, 10 years in medtech with the Swedish companies Elekta as well as Bull Diagnostics. So I will take this short first introduction to showcase a few examples of AI applications existing today in our industry. And then of course when we come to the conversations and then later on to the questions, and of course afterwards as well. Ask me anything on those topics and I'll do my best to talk about them. Please, Helena. So, I wanted to bring 3 themes to this conversation for you today. So I guess that some of you might be familiar with medtech industry, many might not. So I choose 3 perspectives on AI from how I see it in medtech. First of all, the fundamental story on the IoT journey, I think must be seen as a fundamental principle in medtech as well. So of course, by having medical devices in hospitals, in homes, in care facilities connected was the very first step. That's what in the digitalization journey, what created knowledge and data around anything from performance of specific devices all the way to consumer and later on also patient behavior and then also health related data, of course. The pictures I have here is just to show that also in medtech, of course, you have everything from connected devices and then just simple user interactions. Here shown by, for instance, our Medela user app that we have for the equipment, etc. But also, I stole a picture from the web page of my previous employer, Elekta, as well, who have also come to the level where AI is helping in preventive maintenance, etc. So this is very similar to what I would say all industries are doing. That's also relevant in medtech. Okay, so now maybe to two of more specific topics. Next, please. Yes. So I wanted to bring two cases. So in the medtech industry, imaging is a really big thing. You probably are very well aware, you yourself or your relatives, when you go, there's something wrong, some kind of image will be taken. It can be X-ray, it can be MR, CT, I mean you have all the kind of different images that can be taken. If you just take it from the beginning, that of course was a really great evolution in itself, but totally relied on the specialist doctor to be able to interpret the image. So it was really, of course, a great step, but also clearly has its limitations. The example I show on the slide is from the industry of hematology, where I've also been active in both Diagnostics recently. This image is showing an industry example. This is an existing company today who has taken this area to the next level. If you think about when you go, the most basic test you can do is a blood analysis, right? You go, there's something wrong, or you even want to check you're healthy. They will draw some blood and come back to you with all kinds of parameters. This data can be more and more advanced depending on what technology that is based on, and it can tell you more and more about the health status of yourself based on your blood status. Today the limitation is really that what you can have been able to be doing, that's how I should say it, in a cost-efficient way, is to take basic data, and then if there is anything that indicates that there is a problem, it still has been the hematologist who has done the blood sample, a blood smear, and looked in microscopy. That has been the solution. Of course, we have advanced a bit in digital microscopy as well, which has helped, but it's still, again, based on human specialists. These guys on the slides here, called Scopio Labs, what they have done is that they have taken image enhancing technologies from other industries, taken it to an AI accelerated way of handling images, and with very, very limited data from a blood analysis, they can then enhance by the AI algorithms to a full-blown image and understanding, which is as good as it would be in an analog blood smear. But it's even better than that, actually, because the blood smear is not so big. Have you seen, you see it in front of yourself, right? In a lab, it's a really small glass, and they just threw the blood out. This can take really big samples with very little data and then have a very comprehensive analysis of the blood status. Very impressive. So this is already in the market. They got regulatory approval for this just last year, so it's quite recently. But I think this is a good showcase of where AI, without being, it's a really safety critical perspective, because of course if it gets completely wrong, we will miss the diagnosis, right? So there might be a very sick person, and maybe this AI would sort of paint up a really nice, perfect blood sample when it's not. So it's critical, but it might not be super dangerous, right? So it's a good area where we actually dare to advance with AI steps, also in the medtech industry. Medtech is super conservative. The doctors, everything with our health, which is good probably, super conservative. So it's very important it's secure. Third one. Sorry, I'm probably, yeah. And then I took this one. This is a startup company, but this is actually a very common showcase. This is just an example, but this is what I think one would say happens the most with AI. It's in the diagnostic space. I mean, now not helping the doctor to get a good image, but actually do the diagnostics themselves. This is a very cool example. This is a German group who has decided to try to take from very basic blood analytics data as well, and then apply just standard big data conceptual thinking. We have a lot of blood data out there. It's been going on measured since the 50s or whatever. And then see then the pattern and apply AI algorithms to see super early symptoms of different. This one, they are looking at cardiac. You probably see there's a heart in the middle. But you were probably aware, only a couple of weeks ago, right on the news, what if we could detect cancer with a small drop of blood? You heard that? That was on the news just only a couple of weeks ago. This is all about, this is my third case. So in the medtech industries, I would say that these, not the only thing, but three really interesting themes from my perspective. The IoT journey by enhancing quality and preventive maintenance and ensuring uptime in the medtech device space. Second, it's all about taking imaging data and enhancing that so we can take, without too much cost effort, really you apply imaging for all, everyone, everywhere, right? Not only us, fortunate to live in a country where we all get the image anyways. And third, the diagnostic space. So I think those are the cases that I bring with me, Helena, today.
Thank you so much, Helena. I cannot stop thinking of the company Theranos because they're kind of my neighbors, and maybe the AI was actually the missing piece that they didn't.
Maybe. Well, I think might have been
very interesting. Thank you so much. Thank you so much. That was the. Thank you. Our cool cases from the medtech industry, and now we're moving into automotive. So, Thomas, take it away.
Thomas, founding engineer at Enride, so been with the company since the very early days. And this is one of the things we're building. Cabless truck without human in it, no humans anywhere, can't even drive humans. We're worthless in that way, but it's really good at carrying goods. But what Enride does to begin with is selling freight. We sell both manned freight and autonomous freight. It's electric, all of it. And we're helping large global companies to transition their freight from what they have today, which is diesel and human-driven, into electric and autonomous. Hence, we're scaling out large fleets today. We have the largest electric heavy vehicle fleet in the world of heavy trucks. We are live in operations in both America and here in Europe and in Asia and many places. But the focus of today is rather on this thing. Because obviously, when you're driving fleets of electric trucks and trying to optimize how you use all the resources that you have in your system, there's a whole lot of AI that goes into building the optimization engine on certain levels. And the same is also true when you're trying to diagnose your batteries. So how is the degradation actually working in this individual vehicle? And when I'm trying to route it and using it in my fleet, how do I know how long the range will actually be? Depending on weather and a trillion other parameters. That's where kind of AI comes in to break that complexity into something useful. But to continue beyond that, the pod side, that's where I spend most of my time. So this is Gen 2 is what we call it. It normally drives slow speeds and carrying heavy pallets in the back. We're doing freight in for example, in Tennessee and Kentucky with General Electric, and also here in Sweden, moving freight on public roads. But it's super hard. And what I'm rather going to focus on is self-driving technology in general. So if we go to the next slide. So the general way of thinking about self-driving system is this sense, think, and act. So basically, the sensor sees something, you think a bit, you act on something, and then when you act, it changes the environment, and you sense again, and so on. So there's many different approaches to how to go about solving this. So I stole some images basically saying this, that back in 2018, there was a whole suite of companies, and there are still companies that take raw sensor data and just give it to a neural network that is trained, and it would output gas, brake, and steering signals. And somehow you're supposed to trust that. Obviously super hard, and I think we're gonna discuss that a bit today on what you can do to, not have to have this black box that does stuff that you don't know if it's gonna be good or not. There's many other companies or like approaches to it where you split it into certain modules and kind of apply machine learning to them. But I think overall, there is applications of machine learning basically in all areas of this. So just looking at building an environment, a digital representation of what you see around you, there's many ways of bounding the data while it's progressing through the pipeline, all the way of actually progressing towards motion planning. So, and for example, normally you see these camera-based models. I think if you listen to an Elon Musk or something, you're going to hear that like humans have eyes, therefore cameras should be enough to be able to drive a vehicle. But then again, like humans have brains, and those are significantly more advanced than anything we can bring to market today in terms of chips. But the other thing is why a lot of companies are using more different data types is to get more data diversity. So that's why I have radar and LiDAR, because they're good at other things. Let's continue on to the next slide. So I even added a GIF to be able to explain a few things here. So in the motion planning here, for example, normally it's very model-based. There are machine learning approaches where you have kind of to all the systems where you have one deterministic path and one machine learning path, which is normally high performant, and those two together can build something that's potentially safe. But still, it's crazy expensive to build machine learning systems because you need labeling and all these things on scale, and you really need to understand your data thoroughly. And building a AI factory or a data factory that can handle that is fundamentally really hard. But you can see here, motion planning, that will include machine learning. Classification on the vehicles will include machine learning. The yellow arrows or lines you're seeing in front of you, that's impossible to do without machine learning. So when you're looking at the Mercedes level 3 system, when it does prediction beyond a few seconds, then it's a heavy machine learning, and that's things that are being used on roads today. And as the last part here on the right, you can see on top there that one piece, like back in 2019, what all companies were doing was they were adding like 10 server-based NVIDIA graphic cards in the trunk of the vehicle and saying, at some point in the future, there's going to be a machine that's 10 times better than what we have today, so it can fit in the machine. So for now, we're just using this, and it doesn't matter if it breaks. But when you're trying to commercialize this, actually put it in a vehicle where it will survive in harsh weathers, and you have a power budget. Because, for example, with the Tesla chip, when you're using it, it requires about 10% of the total energy usage when you're out driving. So it reduces your range. So it's super important to have your compute in line. If you use those heavy graphic cards, your whole machine will die. So, but what everybody's going towards is specialized chips. And there's a whole myriad of things. Even if you think about ChatGPT, that is based on the Cerberus wafer-sized chips for training, which fundamentally creates different possibilities. And that's one of the bases for self-driving as a whole. So, and that's what it actually looks like when it goes inside a vehicle. Like a clump of steel with some cooling stuffs on it, but it's kind of boring, and that's great. So yeah, that's I think it's a good intro.
Thank you very much. It looks like a vehicle, kind of. Should fit in a vehicle.
Yeah.
Thank you very much. So yes, so now we had an example from the automotive industry and self-driving cars, and the next critical industry that we are moving into is actually telecommunications, and here we have Caroline Jakobsson.
So in Ericsson, we imagine a world where everyone and everything is connected, everywhere and all the time. And then you can think it's a lot of things we can do with that. And I'm coming from our global AI accelerator. We are helping the rest of the company to apply AI and machine learning in as many places where we think sort of it fits. And we can do things that we couldn't do without AI with that now, which I will tell you a few examples on. So next. So basically a little bit first on about Ericsson. I mean, we do telecommunication network, and it all started with network that could handle speech. Then it came data, and with 5G and 6G, we can connect more or less everything. And our network is very critical for a lot of the industries that we will and have heard about. So our telecommunication network is needed for all those industries to communicate. And I have a few examples here. You have the robotics. Let's see what you think about this, Helena. Like example for remote surgery. You might want the very best surgeon, even if he's in Australia while you are here in Sweden. And that, of course, requires very reliable and trustable networks behind it. In the future, we will have like converged digital and physical worlds. So you can have like machine steering a three-dimensional world, and then you have to put like machines or robots, whatever it is, for example, from a factory. You have to sense a little bit where they are, and where they are going, and put them in the digital world to be able to steer it. And we use then AI and machine learning to manage all this. So next. So here are a few examples then of like where we apply it. So the first example here, limitless connectivity. I mean, we say that the network should be everywhere and everyone should be connected. And that is quite hard demands. I mean, if you look at Australia, for example, the countryside to start with, it can be like tens of kilometers between the neighbors, and you need like equipment that can handle really big coverage. And then if you compare that with Shinjuku station in Tokyo, where you have like millions of people passing by every day, they are coming out of the train and all of them are getting onto the phone at the same time. Those are two very different cases, and both are difficult for our network. And we have like millions of sites out there, and they are like in between those and with other additional complexity as well. So then we use AI and machine learning to like optimize each place as good as possible so it works. Trustworthy system. Yes, we have to ensure that they work and that no one is breaking them. So we can use AI and machine learning to detect attacks and avoid them. And we also then use it like to explain what we are doing so it becomes understandable for our customers. With the cognitive network, we want to give our customers the possibility to steer a little bit more and easier, faster, how they want it to work. I don't know, for example, maybe they want high throughput in the weekends because everyone is looking at video, I don't know. And in the weekdays, maybe they want to save energy because that is very expensive. And then they can adjust what they want for the moment. And then we have like hundreds of algorithms in different part of our products that has to be tweaked to do like what the customer wants. So that they will get with the cognitive network. We also have another thing that is good, and that is that our networks are like all over the earth, more or less. And that means that we can also use the compute we have there for other devices that maybe doesn't have so much compute, or that have to be very cheap, or with long battery lifetime. I'm thinking about your helmet there, for example. Maybe that helmet cannot be very big, so we can use that one offload, so the machine learning can run on our compute in our network and help the bicycle man not to collide with a car or something like that. And last but not least then, the sustainable world. And here, I mean, we think generally that the telecommunication network help with sustainability because, I mean, you don't have to travel. You can meet electronically, for example, and that is very good for sustainability. But we are also spending quite a lot of effort to reduce the carbon footprint of our products. And here you have like a balance between saving energy and getting the really high performance out. So we can then apply AI to help us predict if it is okay to turn off part of the network that you don't need. And then, of course, it has to be turned on before the industry or the different use cases needs it, because otherwise it's too long delay. So that's an even harder problem to sort of predict when to turn it on again. So basically, for us, AI is a very powerful tool to help us achieve all these things that makes our network then very stable and reliable and useful for those use cases. Thank you.
Thank you, Caroline. And last but not least, we have Shiva representing ABB. Yes. You want it?
Different from the other presentators. And the question is that, I mean, of course, you would like to, oh my God, AI use in ABB, but you will not see many of that after this slide. And the reason for that is that we are not, I mean, we are quite an old company. Our product portfolio is very big, and picking up just one or two products, I don't think that it makes it right for ABB. So I took the approach to look at our products, who we are, what we are doing, and then trust me, just bear with me. I will show you how it comes to AI in ABB. So we are a big company, more than 100,000 employees, and our operation goes through these 4 business: electrification, motion, process automation, robotics, and discrete automation. And by adding software to all these portfolio, we push the technology towards, I would say, limits when it comes to performance, so to say. How do we do that? If we look at our purposes, starting with creating success, yes, we love, as all of you, we love success. We do it together with our colleagues, but for the most, together with our customers. That is, starting with challenge-driven innovation projects, we try together solve the problems that is really a problem. Second, addressing towards energy challenges. I think that nowadays I don't need to, everyone knows what we're talking about when it comes to the energy challenges. And here there are lots of questions to be answered and be solved. Transforming industries, helping together with our motion, electrification, and process automation solution, helping industry to provide the maximum efficiency with minimum footprint is something that we really believe that we are helping them to do that. We also envision that the physical and digital world will be merged, and that is what our solution will help them to make that happen. Embedding sustainability. Sustainability is actually very, very important in everything that we do. And we usually say that sustainability is not limited only on emission and raw material and so on and so forth. Sustainability is very much also about the human values, and all of these things that we are really, really care of. Leading with technology, I would say that, if some of this is quite obvious when you talk about the brand ABB, is leading with technology. And the, I would say, main source for doing that is our personnel. So what does all of this do with AI? The fact is that in order to make this journey faithful with these purposes, it is obvious, at least for me, that you need to use AI, among the other things. So as an example, I would say that AI is one of the key enablers that help us to make our robots more collaborative, make our robots more easy to use in order to eliminate these 3D, dirty, danger, and dumb tasks for humans. That is thanks to AI. AI helps us that when it comes to industrial solution, we can predict, or I would say react on the non-seen happening in the processes. That is thanks to AI that we can do that, and we do that. When it comes to energy, we know that the energy system is complex and becomes more and more complex with several providers as well as users and distributed grids and all of these things. It requires an optimal and flexible, I would say, prosumer management, energy management, to do that. And you cannot do that if you do not use advanced, I would say, data-driven approaches like AI. So we use AI in everything, but when and where it is adding value. We do not use AI. We are not, I mean, we do not market any of our products on the label of AI. Our products are labeled by performance, by what they are offering to our customers. So.
One more.
Okay, yes. So let me end with some cool, as you said, use case.
The first step of the process is to drill holes to place the explosives inside the rock we want to break. Inside each hole, a primer is used to initiate the explosives. Several types of explosive products can be used to charge the
how
holes.
the operator should load.
Essentially, the holes are filled with either packaged or bulk explosives.
And one more.
So, and here to the right, you see what I was talking about. It is one of the D, or maybe two of those Ds. It is both dirty and it is dangerous. So this project started 2013 on the right, I would say, at the corporate research. And then the picture up to the right, it is the first test 2021, October in Garpenberg. And then we have taken the next step using collaborative 2 robots together. And the idea is that this guy is sitting up to this vehicle doing this loading. Now instead, no guy will sit up on that and doing it. 2 robots together will load, as you can see. And of course here, both when it comes to vision and image recognition, and all of these things are used to make it happen. As you see, it is almost ready for the prototype, and it will be launched in 3 weeks, I think.
The first step of the
Whoops. Thank you very much, Eva. Brilliant. So please come now. We start the panel part of this seminar. I was thinking to make it a little bit more interactive, so you can, the audience, please think of some questions along the way. I have my questions to the panelists, of course. We'll try to see if there are any common themes here. You've seen the industries are very different. There are different needs, different use cases. Maybe one common denominator is that we want to eliminate these critical use cases, as you saw Shiva was showing. The person is actually sitting in the control room compared to in a very hazardous. And Thomas, you don't even have a driver in your truck. So that's fantastic. But let's start the discussion, and then I will pause from time to time. We have a microphone in the room, and Karin will help to give you the microphone here. So let's start by just definition of trustworthiness. I come like many years ago. I was working with safety critical systems with no AI, and we would do formal verification. And that was very trustworthy, because then you know for sure. But with AI, we cannot give 100% guarantees. So how do we define trustworthiness of AI? Who wants to start? Shiva.
Yes, and you know what? I thought that's maybe the best way to get the definition of the trustworthiness of AI is to ask ChatGPT. So I just read it for you. I think that he does a very good job there. Trustworthiness of AI refers to the degree of confidence that individuals or organizations have in an AI system to behave ethically, accurately, and reliably. This includes factors such as transparency, accountability, security, privacy, and bias-free decision-making. Trustworthiness is a crucial aspect of AI as it affects the adoption and use of AI systems in various applications, such as healthcare, finance, and autonomous systems. So I think that this definition is very good, but I was a bit, took the next step, because I was really curious to know what does ChatGPT thinks about applying AI in safety critical systems. And the answer that I got for that was even better. AI in safety critical systems, such as autonomous vehicles, medical devices, and military equipment, can offer significant benefits in terms of efficiency and effectiveness. However, it is important to ensure that AI systems are designed, tested, and validated to meet stringent safety standards, as failures in these systems can have serious consequences. This requires close collaboration between engineers, researchers, regulators, and stakeholders to establish best practices for developing and deploying AI in safety-critical systems. And if I may, I have one example that I would like to share with you. I mean, we all have heard about Boeing 737 MAX. You know that? Yes. The history, I mean, if we go back, what happened? What happened was that they got the, I would say, task to design, keeping the very same 737 design, just decrease the fuel consumption. One solution for that was that, okay, we can use a bigger engine. Yeah, we do it. But the problem was that the engine didn't fit under the wings. Solution? Yeah, we push it there, and then we try to control it with a with an electronic system, namely maneuver characteristic augmented system, something like that, MCAS. That is, when it becomes unstable, then we draw the nose down. What happened? I mean, if we just freeze there, the main thing when it comes to the safety critical systems is that the requirements should be included already in design. The first step that has been not followed is that was number one. But it was not the end. It's followed with some other things like, for instance, angle of attack. It was only one sensor, and the other one was that the pilot had not the control of the wings, and la, 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 la. And the result was not, actually the worst thing was that they didn't include it in the document either. Why? Because if they had included that, then the training for Boeing 7, the ordinary, should be stopped. So, what I want to say is that we usually say under the shell, you can do whatever you want to increase the efficiency and productivity. But keep it caged in a shell of security, following the standards. That's at least what we do at ABB.
Right, and it's true. The more complex the system is, the more risks there are. And thank you for taking Emil's role. He was supposed to talk about aeronautics, but you took it.
Is that so? Okay.
All right, any other takers?
Can I just comment?
Please.
Because I think what you said, Elena, this about how it used to be deterministic, with all the verification and validation. I think it can also be seen a little bit, there are actually two steps, I think. One thing is to use AI technology to develop a product. Now I'm talking about my industry, right? When it's really, really heavy regulated as well. And then verify it anyways. Stop the learning. Now we have something, we didn't really know how it came to this conclusion, but it looks good. We verify it and validate and release it. And then, of course, the next step is then when we allow it to continue learning after a release. Then I want to send you one question to think about. And that is in terms of actually equality over the world. What do you think? How good does an AI-driven diagnostic or treatment handling have to be acceptable? Does it have to be the best surgeon in the world to be good enough? Can it never make a mistake? Is it good enough if it's average? Or is it even okay if it's in the bottom 20%? Because of course, you will find people treated by the bottom 20% in the world as well, right? So that question, I think, is to be trustworthy. It's also an acceptance thing. It's not only...
Just to comment, as a father of several doctors, I mean, we release newly trained doctors all the time.
Yes.
And they are not top 10%.
not starting there, at least.
Yes, yes. Very exciting. And we can continue on the topic of human oversight and doctors. And now that we have, well, I can speak for myself. I have a car that can drive itself. And by regulations, whenever it gets scared, it says, now you take control. Because I want you to be responsible, because I don't know how to do. Very interesting and similar, I imagine, happens in other industries when a device is making, or an algorithm is making a proposal, and then it's a doctor that acts, right? How do we do there? Helena?
Should I start?
Yeah.
I think it sort of relates to that as well, because today it's a lot based on the fact that there is a human doctor, in this case, signing off. So you can have super advanced equipment, but at the end of the day, the final control that we trust in society today is one, and it only takes one actually, one human doctor to sign off a diagnostic result, a treatment plan, or whatever it can be. So the difficult question here for me then becomes when the AI-driven approach based on, I don't know how vast amount of data, analytics, come up with the conclusion that if you have a combination of, let's say, low value of parameter 1, high value of parameter 3, and then also in combination you seem to be limping a little bit when you came in, the doctor will not understand that they are connected at all. But the AI-driven approach can actually have seen a pattern. When people have that's a super early sign on a very severe or advanced, diagnostics, a cancer or whatever it is. Will that doctor then sign off? Here you have the AI equipment say, I think you should go into surgery immediately. And this doctor, no, this doesn't look so bad. Have you been crazy? And I think actually you had such a great example, Thomas, in your film, when you had the model-based path compared to the AI-driven path. In healthcare, it's almost always the doctor that is at the deterministic path, trusted to be. Of course, you have model-driven equipment, but the final trust is given to the individual. So I think then it becomes so, to your question, Elena, so important. How can we present to the human being, also in the car, by the way, but now I'm talking about this, to the doctor, in a way that he or she understands? Because this will be highly irregular suggestions, probably, from a doctor's perspective. Looks really very strange. This, in your case, the model-based would have won 1,000 times. The AI has gone crazy over there. It wants to turn right there in the woods. But it can actually be that is the right thing. And I think that's so important then. How can we make the man-machine interface in a way so that the human interpreter can trust what the AI-driven approach conclusion is? There we are almost nowhere today, I would say. Or nowhere, but long way to go. That's my thought.
Thomas, can you comment on, do you have a sign-off of a human, or do you have algorithms?
Yeah, I was exactly thinking of that. So in the industry, for some time, people were talking about these L5 vehicles. So there's a scale of 0 to 5 automation, which doesn't make any sense, but people used it anyway, especially for autonomous vehicles. So that's why if you look at your typical Tesla, that's an L2 system. And then people have talked about L3, which is very unclear exactly what it is. And then it's L4, suddenly the machine is in control. So what the industry seems to be saying now is rather that all machines that are eyes off and hands off will still have some human remote supervision. And what is that? Well, in our case, we have a remote operator that supervises certain stretches of road where we know there's problems. Because at any given time, the vehicle is always responsible for its safety. But that doesn't mean it needs to be able to handle every edge case. It needs to be able to get to a safe state and then have a human supporting it. But that way, one human can supervise many vehicles. And over time, you can, of course, increase the performance and solve these issues. But suddenly, at least, you have human supervision to some extent. But what's important is that the human supervisor never has accountability for what the vehicle does. That's down to verification. And also, I think there is this premise out there about that you should compare autonomous vehicles to human-level performance. That's, I think, is a fallacy. It's a big fallacy. Because a automated system like that, if you know there's a flaw in your system, you can't send it out there. Because if you stand there and kill somebody and you knew you had a flaw, you had looked at your frequencies and severities and said, well, this is okay, and it actually isn't, then you're in deep water. That's where your company dies, especially in America, where you've probably exposed thousands of people with your other vehicles that haven't run into anybody. But because it's a commercial entity that's responsible. So I think it's important to really distinguish that, and that's why I think being able to have these trustworthy systems which are accountable, but always with some sort of human supervision, that's kind of our way to go. And I think the industry in general is converging there as well.
Yeah, very interesting. Let us touch upon the topic of data. I can say I've been working with AI at Ericsson for about 15 years. 15 years ago, we said, our problem is that we cannot get hold of data, and we don't own the data because the customer data. And imagine what, 15 years later, we still say these things. And what we were talking about, I think you, Helena, you mentioned when you take a blood sample and it's just so little, can we do some good out of so little blood, so little data? So what can we do to compensate? Caroline, can you start?
Yeah, I mean, it is exactly as you say, Lena, that the customer owns our data, and we don't always get it. Maybe they are not even allowed to take it away from the country where it's stored. But I think we also have the problem that our products of today doesn't necessarily generate the data we need to build those very reliable systems. So then it becomes like a catch-22 towards getting it going if you don't have the data. So what we are doing is that we have simulators, or you can call it digital twins. So you can time travel a little bit and see how would it work if we were making a certain change. And in that way, I think we can predict a little bit how something would work. And while we are doing that, we are also collecting and generating the data so we can use it. And I think those systems becomes better and better, I would say. Earlier we had more statistical models, but now we can use maybe central London, we have all the houses, we have topologies, we have the radio propagation. So we get quite good views of reality. Obviously not reality, but still quite good. So we can, it's really useful for us. Then I think there are also this synthetic data, which is more like when you mimic maybe what your customer have, their customer data to predict churn rate or something like that. And then it's more that it has the same statistics as the data you're looking upon. And I think that is useful in other cases when you're not investigating your own system really, but trying to do something for the customer without them having to release the data you have. But yeah, we think it's a good first step. Then obviously when you come to reality, you want to tweak it, I think, to get it even better.
Let's see, Thomas, do you want to comment? I'm very curious how you experiment in live systems. So.
Oh, yeah. I was going to say synthetic data is a big topic in the industry, because obviously you can't collect all edge cases, and then sometimes you want to create them. So what people do a lot is they collect a bunch of real data, and then they create variations. They might have models for creating variations, and sometimes it's even crazier than that. You use generative networks to create variations of your of your cases, and then you make sure that your system pass all of that. And if your system performs significantly better than needed in simulation, maybe it's actually good enough to work in reality. But simulation is one of those key technologies, because I think early on in self-driving, there was this thing, basically go out there, drive enough miles, it's going to be good enough. But then somebody forgot about that the thing with software is that you need a continuous deployment loop. And the latest version is always the one that's, the one that matters, not what you've done previously. So setting that up, and then for being able to do that, simulation is one of those critical pieces. And the trickiest part now that is in the industry is like, how do you simulate sensor data? Because sensors have different physics and very different characteristics. And that's a major topic. And when you train your system on that synthetic data, like how do you view that compared to when you're actually going out there? So I think most cases now, it's maybe 10-20% of synthetic data they can possibly get into your system, depending on application, of course, and many different things. But what you want to get to is significantly more, of course, because then you can really basically simulate everything and know that your system can't be fooled.
Fantastic. Now I want to check with the audience. Do we have any questions from anyone? Yes, we have one. Now the microphone is coming. We have more than one. That's great.
You go first. No. It's streamed. It's more than 100 people listening.
Okay, then I start with a question here about this. We always talk about that we can learn and train a system, and then the question is, if we haven't trained it on some situation that could occur. I was thinking about, we had built nuclear power plants, and then if there was a break in the piping, what will happen? And they have been thinking about everything, and then suddenly there was an accident where you had the water was destroying the insulation, so it clogged the filter dramatically fast. No one had thought about that. What happens if you have the same thing in the AI system? Something that no one has thought about, and then suddenly it occurs and happens. Can we trust that the AI as such will create their own test system to handle these type of things, or is that too far?
Any takers? Shiva, please.
But actually, we forget something here, and it is, this is not new for automation systems. I mean, we always, when we automate things, there is always, we are talking about the uncertainty, probability, and so on and so forth. So the fact is that regardless if it is an AI, or I would rather call it, if it is an artificial intelligence or a real intelligence, doesn't matter, okay? Both of them should be challenged, should be evaluated, and should be caged. That is, you need to always assure, first of all, calculate on what is the probability, two, what is the hazard coming from that probability, and based on that, and that is the journey that automation system has done during the last 100 years. And there is so many, I would say, standards that are really working well. So I really don't see, doesn't matter which application. It's just use it as it is, not replacing the human, not replacing what we have learned during all the years, but combine it. Use it just to, maybe I'm old-fashioned, I don't know, but I feel that we are very much focused on that. Now, why should an artificial intelligent-led doctor have less responsibility than a doctor? I mean, you know always that if you are sick, and if it is a really critical sickness, you choose a second opinion, don't you? Always it is very much usual. And that is exactly the same. Using artificial intelligent doctor together with the doctor, it increases reliability. And I think this is the key that we should, sorry.
Caroline.
Yeah, I think I agree with you, but I think also that we have to look upon the weaknesses that we have them with the AI system, because I mean, you can really, if you understand which data you have, what that is representing, you can also liberally test if it's totally out of bound what happened and see that it sort of behave pretty robust. And I think if it's an AI system, maybe you can't say that it's due to what you said, this isolation. I mean, because it might be hard to like envision the scenario where it happens. So I think like more looking at data totally out of bound and ensure that you have a good view of what happens if it is like that. So I think there are like looking upon the verification from an AI perspective, make you take at least a large portion of these, I think. Probably not 100%.
I want to comment on what Shiva was saying. I like how you use the term caged. And I have this mental model of collaborative robotics that we have like a bunch of robots that are caged because they're dangerous, because they're not reliable and you're not allowed to let a human inside. But now they're not caged.
No.
Now they're collaborative and they sense that there is a human inside, but the algorithm is caged.
Exactly.
Which is very interesting. Yes, we had another question,
We
right?
have 3 questions.
Yes, perfect.
Thank you first. You had a question?
So it was very nice because I heard a lot of things and I will have thousands of questions, but I focus only one, because listening all the presentation, it is not clear to me what you consider artificial intelligence is. And listening the last one comment, it was very nice because you said if my doctor say one thing, I ask for a second. So we need to create 2 artificial intelligence. One that asks to the second what is the opinion and then decide. So I think that the first question is what we consider artificial intelligence is, because almost all the things that you presented, there is something which is robotics, automation, calculation, software, machine learning, and so on. Intelligence is something which is higher level. So I consider intelligence what make us capable to decide under the knowledge we have, but make us possible to answer even questions we never get before. So with no data in advance. And you, without data, can do nothing. That's the point.
100% true. Anything?
Yeah, one thing that pops into my head on that is like.
Thank you very much.
Without data, we're nothing.
So one standard that is well aligning in the industry is using this ensemble of networks, where you have different data sets trained with different models, looking at the same data and trying to take a decision. And when you have this ensemble, maybe 8 voices, 8 different networks, which is of course expensive to create, but that is becoming cheaper and cheaper, then you can take a decision with much higher reliability. And then you get back to what you said before, it's still frequency and severity, always. But that will at least give you a much higher, like better answer.
Shiva.
May I just comment on that? I totally agree with you. Of course, you increase the reliability of your system on that. But there is also something that it calls common cause failure. You know that? I mean, if you do have a redundant system, or if you do have a concurring network, if you do have common cause for failure, both of them will lead to the same fault. So, of course, you increase, but you can never be sure, even if you do have 2 channels to make that.
Exactly.
That is really.
But I think also commenting there on your, I mean, if we have like more generalized AI, then it's more difficult to ensure that you have sort of checked all the different possibilities, basically. So, I mean, what we are thinking a little bit in those cases is to try the proposal we got before we really implement it, as a way to sort of safeguard in some system on the side or in some way.
We had more questions, right?
Vi har 3 mer frågare som anmält sig.
Okay, perfect. Then I don't need to work.
Carl Bergman, head of R&D in Vattenfall. I mean, we trust a lot of other types of technology in critical systems today. And over the years, we've trusted them more and more. Fly-by-wire, all our hydro plants are remotely operated. There's no personnel. We just trust these systems because we've sort of gotten used to them. And I was thinking, AI, is there a real difference? Or will we just get used to this technology, or is the label AI actually making it more difficult for us to accept the risks? Because at the heart, I mean, humans make many really stupid decisions all the time. I could.
Very good angle. Please, Helena.
Yeah, maybe I could start, because I think I've actually been sort of having those kind of thoughts myself as well, what we call it, because it comes also back, I think, to your question a little bit. What is even artificial intelligence? It sounds very sort of uncontrollable and so on. From a medtech perspective, and this of course is speculation, it's only for me, but I'm pretty certain that it will. We are very close, that's what I think, to the tipping point of seeing the benefits, so that we will actually learn to trust also when we don't completely understand how it got to these solutions. Of course, we have the data, we talked about that already, right? But I think that the benefits from a health perspective will be so clear that we will find much quicker diagnostic answers with this. So the trust will actually tip fairly soon, I think.
I guess in my head, things that pops up is like, of course, it's just an algorithm. Like you're gonna get used to it. It's gonna be bounded, and it does something inside of there. And who cares as long as it's within the bounds? And I think over time, if it works, it works. But other things here on on self-driving systems is when you do stuff in simulation, you create a bunch of bounds, and when you have a failure at some later point, you can go back and look at what verification was done and fix the issue. And over time, that's how you build an even better system, even though you're not knowing what's happening inside. And that's just a very high control of the data and how the data leads to results. Kind of.
Yeah.
We're believers, as you can see.
So I work in medtech, and we've seen 4 years ago in radiology, you heard that the radiologists were scared of being replaced. Today they beg about AI because they have no chance of coping up with the workload. And I think we already trust this without the human in the loop. Everyone would like to have a human loop. But for mammography, it's very, very close. You have an AI driving up sensitivity to a level with the risk of missing something is low, but it still exists. But you trust it because the alternative is no diagnosis at all. So we already passed that tipping point. Mammography in several countries now. In Sweden, we do double reading. So two doctors should see every image. In Värmland now, they run an AI, and if probability judged by the AI to be low, you only do one read. And it's very, very close. You do no reads, about 30% of the women. And that's because otherwise you get no diagnosis at all.
Yeah.
That's similar to 2019. Every event I went to was always like, you're going to take drivers' jobs, and all of them are going to be out of jobs in a few years. And then COVID happened, and then a few months later, everybody's like, when can you have it?
Indeed, indeed. And maybe we can spin a little bit more on computer vision, because I think you all kind of use computer vision, and it's not only for visuals. I mean, you can use computer vision for more use cases. Can you comment how you use this? I mean, in your case, Thomas, that's clear. You have the cameras and lidars and everything. But
yeah, but I think the camera has a particular role in the system. The LiDAR is really great at like depth sensing and radar, it velocity, and it's super robust. But the camera can detect, like if a car is open, the risk in the vicinity of it is significantly higher. And when you're doing predictions, that's something that's super useful, because you can certainly start thinking about what things are going to do in the future. And camera is like the most critical unit for that. But then there's, of course, many different approaches to how you build out such a network, but and run them. But yeah, it's really bread and butter of of things, but the really hard thing is doing safe system with cameras. And there is still missing system. And hence I mentioned the ensemble approach, where you have networks voting, that's one way. And then there's emerging ways of making sure that you can bound some of the outputs, so you actually know deterministically at least some about what the system will do. But cameras is a tricky topic when it comes to determinism. And that's why it's high performance path, but not necessarily as deterministic. And that's why other sensors are great.
Good. Anyone else? Shiva?
I mean, the robotics case, everyone knows about that, but maybe can be relevant to say, for instance, in pulp and paper, we have had web cameras for detecting of the quality, and now it is more and more used in other process industries, from food and beverage to metal industry and so on and so forth. So yes, definitely, when it comes to image processing, I would say, or in our case, I believe more to multimodal approach, that is combining the camera output together with the other process data that we have. It is really strong and it's really efficient. So,
great.
Absolutely.
And I think, like for us in the telecom industry, I mean, we are using it as well, for example, to inspect sites. So what we have is that different operators, they are sharing the towers, but they don't really know what they have up there after a while, and they don't know what their co-sharing have. So we can have cameras in drones, for example, and figure out what is there, is the cables correct or not. But I think we are also using it like one-dimensional computer vision, you could say, to detect on the radio signal, for example, for microwaves, if some disturbance is due to rain or due to a truck, or if it's false, so we have to go there and correct it.
And maybe I think, Caroline, also I'm coming a bit to your presentation also early on, because I think also when we talk about vision, and especially maybe not only like vision, but any kind of remote access to data, then of course the trustworthiness of the networks becomes super critical. And that is always been a big topic. You and I have had a journey on that, Elena, as well. The resilience, because also some of these calculations, of course, can be super, you talked about that as well, how heavy powered they need to be sometimes. And also maybe you want to do edge or cloud computing support in real-time cases. And then, of course, the vision is not only the quality of the vision. I think it's not actually the major problem, but that you can rely on that you have it there and don't lose it.
Great. So we have more questions from the audience.
Thank you. Please may make a short comment to your mention about the Boeing 737. Pardon?
Introduce yourself, please. Vem är du?
Okay. Can I just talk? Is that all right? Okay. I'd like to talk about the 737 MAX 8. You mentioned that, and I think that they should have had artificial intelligence when they modernized it, because they did not have any human intelligence there. Two teams working, not talking to each other. They were pushed by the Southwest Airlines to make it a short time, make it cheap, and they had only one channel. I think you mentioned 3-channel systems for the angle of attack measurements there. So that they made, in my mind, approximately everything they could do with so-called human intelligence. They should use AI.
Good comment.
Starting to trust the systems. What if something really bad happens and it turns out to be a really simple error? I mean, ChatGPT, fantastic, but I've also seen it miss by a mile. How do you divide 120 by 5? And I mean, most of us can do that in our heads, but it just went. It got to 10, was the answer.
Plus minus.
And try again. But I mean, how do you deal with that in meds, for example? If you have you could kill the industry or the application if you have one such case, and it becomes apparent that it was how do you address that?
But if I start, and I think it's relevant, right, for all industries, I think we are back to that discussion. How good does it have to be, of course? It's a little bit, of course, the topic also of the consequence. We are back to that risk, what is actually the hazard perspective. But there can always be, I mean, severe mistakes. That has gone for all technologies, I would say. We are talking now about this system and voting, etc. I mean, I remember all the way back at KTH days when the Ariadne thing had happened just a couple of years before. Now maybe someone is super into that history, but I remember we had that as a use case actually as students. That was exactly what happened. They had and that was way before AI, right? And a terrible accident that happened that killed people, etc. But the industry was also still there. So I think that's a bit, for me, that's not AI specific, but the general technology perspective, actually.
I think on that, I'm thinking of the 737 MAX, but aerospace cases in general. Like in the 60s, people died all the time in airplanes. But every time there was a severe accident, you would do this analysis and look at what actually went wrong. And then you added regulation. Now it's a super regulated industry. That's maybe not good in always either. But still, over time, safety got better and better and better because you knew that requirements for a safe system. And as long as you can show that, well, we did the work, we did the analysis, we did what was feasible, and it still happened. It needs to be okay to fail if you did the work and did the weighing off of the risks.
So that the people will be pushing
So I'm also sort of thinking about having control of the data, because it's all start with the data, and if you know, at least it's a very good start if you know that you have high quality data and the right data to take the decisions on, sort of. Because I think this ChatGPT, for example, it learns from the questions we are putting. So if you put a number of stupid questions and assumption there, suddenly it uses it 5 minutes later. And that you cannot have in safety critical system. You have to only feed it with data yourself that you know is the right data and that you have control of.
And cage it. As
Yeah.
Shiva said.
Yes.
So since I cited ChatGPT, maybe I need to add something about that. I mean, the reason that I took it, I mean, if I listen to Jan Lacondo, then I shouldn't even ask, because this is not Q&A, according to him, and I should maybe trust him. But the fact is that all of this algorithm and AI and so on, and you should not think that I'm against it. I love AI, and I really like it. But the fact is that we should not interpret it as another animal, as very strange or so. It is, I mean, it is exactly the same as all the other tools that we have had, a bit more intelligent. And because of that, I mean, the fact that with the data, as it was mentioned, we should not really forget that a software has never failed, will never fail randomly. That we know, okay? If there is anything wrong with the software, it is systematic, okay? And if you eliminate all kind of systematic faults, what is remaining is the trigger of your software. That can be changed. That can be, I would say, not deterministic, non-deterministic, and then it can the behavior of your software can be totally changed. So one example is that, I mean, if you do have a software that has run 10,000 hours without failing, what is the probability that it will run 10,005, the next 5 hours of running? Only 50%, even though that you have trained it with 10,000 hours. And that is something that we really need not to forget.
Can you comment on the role of standards in AI?
Very important.
Are they making us slower?
The standards itself doesn't make it slower.
And regulations?
And even regulation, if you put right people to define that standards, then it is not bad. It is really good. I mean, I look at the Fredrik, because I mean, when it comes to ethical AI and all of these things, there is a lot of work that's really important. The checklist that they have created, I really recommend it for everyone to follow that. This is really good.
I think the other issue there is, if you don't have any standards, like how do you explain to somebody that you're safe? If you have a safety critical system that other people are supposed to trust,
Exactly.
what do you do? And I think with some of these super severe things, like then you need to show that you've done the work, done the things, you have 50 redundancies to make sure it never happens, if it's the Fukushima thing. But yeah.
Anyone else? Standards?
So of course it's almost obliged. I mean, if this would have been a medtech seminar, it would probably have been 50% about the regulation and perspectives, etc., because that's how it is. But I totally agree with you that it's a way to actually stamp mark. I mean, what the safety and security is. We will need it. I'm with you completely.
Yeah, and as you comment, it will find a way to find a way to kind of find a hole in it, and then the standard is changed and regulation, right? Right, we had more questions.
Three more questions.
Yes.
Did you still have a question?
Thank you. Guo from Scania. So I have found some interesting comments from you. So first, we know AI has quite many definitions or categories. I think the question or the topic we're discussing here is because the deep learning is leading the field in past about 10 or 15 years. So we are using machine learning methods to find the hidden pattern from the data. If we don't have the data, maybe this AI paradigm cannot be applied in this industry, like in nuclear power station, aerospace, or railway. So here, come back to your question about how safe is safe enough, how many images we need to validate for that medical care diagnostic system, how many miles we need to test the autonomous driving, and how much data we need to use for telecommunication to identify things. So this kind of how X is X enough question bothered us too much. I think the problem is we don't have a quantitative measurement for this X index or like safety here, because we are living in the 3D world, but that AI, that feature is hidden in a high-dimensional function we cannot understand. So we use a simple index, like a metric, safety or mileage, or the volume of data. So I feel this is the nature of why we are so confused here and discuss how what is happening and how can we solve it. Thank you.
Very good comment, thank you.
Yeah, I really like your comment, definitely, and also this about the high dimensional situation. I think it actually a little bit relates to my conversation, which is also why I think the interaction with the human is also very difficult, because it's very difficult to present the high dimensional perspective to understand that, because it's not almost human impossible, right? So I think the only way we probably have today is to use your X and say, at least we trust it because of this, to a certain extent. But I think you had a very interesting comment. Thank you.
Thank you. Do we have another question?
Ylva Hambreus Björling. Maybe this is, it mixed my head. You talk about AI for safety critical systems, and then you say that using AI for safety critical systems require controlled data sets. Then I wonder, is it still then AI?
I think yes. Well, just the definition, basically a software program can also be an AI. Like the actual definition is pretty stupid of an AI. So as long as there's automation in it, you could call it that. Even I remember games from when I was a kid, you had AIs in those, and those were made by humans, rule-based. But like sure, there's always like a span.
You also talked about that the system is self-learning, and for me that was part of the AI definition, and having a controlled data set may not be a self-learning system. But I heard your answer, so I'll go home and think it over again.
But I
It's
think
one kind.
I think control data set is that is not the same thing as a fixed data set. It's still kind of, you still get the data, but probably you are pruning it or like making sure that it's not biased, not no bad data coming in as for learning, and then you like deploy it in the reality, and then it's not control data anymore. Yeah.
My name is Sonja Berlijn from KTH. I was wondering how to respond to your questions. How can you train humans if you don't have data set? I think, are we not too pessimistic here in this discussion towards AI? For instance, one study, one research project at KTH where we randomly selected a number of scanning breast cancer imaging pictures. It showed them the AI discovered 2 cases that no human, not even 2 or 3 doctors who were in a reference group detected. Isn't it time to start to reverse thinking? It's like what actually are the benefits or the return of investment of AI? Because actually AI saved the lives of 2 women in Sweden. And I have a number of other examples where we have been learning AI with artificial data because we didn't have the data, and then we could discover problems. And if you have no data, you cannot train humans either. So who is going to be better, the human or the AI? And I love this, everyone knows this discussion, who shall the car hit? Shall it hit the grandpa or the grandma or the grandchild? I mean, these questions we never ask humans. So maybe a human will do 50-50, 50% will kill the baby, 50% will kill the grandparent. But when we have AI, we can have these discussions. And so are we not too negative to AI? Because I see a lot of opportunities. In the power sector, we have seen that AI was 75% better than humans. So we're not talking about marginal improvements, we are talking about significant improvements. So are we not too negative here? I find we talk about risk, but what about all the opportunities that are there? And what about in areas where we don't have access to a doctor? I mean, if we could have a chatbot or an artificial doctor that is at least 20% good of the top best doctors, we could save many lives.
Brilliant. Thank you for this comment.
Yeah. No, but I think that's exactly what I meant when we talked about this equality over the world. I'm with you completely. And I think also if we even here to your example, dare to choose AI even if we are in this world for efficiency reasons and financial reasons, just imagine how it is when there is no doctor. And of course, when you said we always take a second opinion, there are so many people in the world who don't even get the first opinion.
Shiva.
I'm sorry if you felt that we are so negative. That is not by, really it was not. But the fact is that I believe that everyone who is sitting here, we are all agree that it is fantastic. I said that, I showed you what is our purpose of everything that we do. And I said that we cannot reach any of them without AI. So that is no doubt about that. But the fact is that do we want to have AI as a replacement or as an augmentation? And the answer from my side, ABB, is that it is augmentation. That is, we augment the human to be even better. Human is not always good. As you say, cases like the one that you are talking about, AI is definitely much, much better than human. But the fact is that that doesn't lead that we are going to replace human with AI. We say that, why can't you use this into your benefit? That is, a doctor can use all these tools, create trustworthiness to the, I would say, patient, and to her, to him or herself, and then everything is fantastic. Human together with AI, I think that is the way that we should go, and not replace the human.
Symbiosis.
We can have the debate on that one.
We can have it.
Yeah, because why should you try?
And not without the microphone, and we have only 10 minutes left. Shall we have the last question here?
Yes, we have the last question.
Sorry, Sonja.
Yes.
No worries.
Hi, Vinuta from AI Sweden. As you know, AI research is moving very fast. So how would you integrate research, cutting-edge research, into safety-critical systems?
It's a tricky one.
How do you do it?
I know, like in my industry, a lot of companies are experimenting with like transformer networks and using them in actual real things. Still not there, and one piece there is also that the silicon isn't there to actually do that properly in an efficient way. But I think it's still a tricky one, because when you get something to work, you don't want to replace it. But I think the big thing with AI is still that there is so much performance still to get out. If you stay too long with the technology that's moving super fast, you're going to be left behind. And then I think just the value of being able to switch to the next and next and next will be higher, maybe more than with previous technologies. So maybe that's one type of answer, but I don't know if that's any good.
No, but I think also that, we are constantly scanning what's happening out there in academia and in the marketplace, and bring everything in that we think makes value for the company. But I think it's also important to judge that. Is this useful for us? Should we take it? And then we do it, but not like jump on everything without thinking about what it should be used for, basically.
And maybe I can comment as well, because I actually always say to people that are not in medtech, that I explain always as a step number one, this is a super conservative industry. On the other hand, my passion I have for medtech, the reason why I'm here, is really to bring innovation to this highly regulative and conservative business. But I think actually your question, I think, should be almost in two perspectives. One thing is to looking into and doing research with the cutting edge technology. Another perspective, of course, is when are we ready to actually apply it. So I think you are very fair to question, do we actually look in the most cutting edge perspective fast enough, at least for research phase? That is a very, I think, fair comment. Of course, some do, etc., but could be done definitely.
Shiva, do you want to comment?
No, actually, I totally agree. Believe it or not.
I would comment, it's always difficult to bring research into productification, right?
Yes.
That's a common problem, right? Or not problem, but we know that it is like this. But with AI, it's special because it develops so fast. So, you need to do it in an even higher pace, which is, a challenge. And with that, I would like to thank this amazing audience for all the questions, and I would like to thank this amazing panel. Thank you very much.
Alla ni som ska äta middag, följ med Linda här. Linda tar med er till middagen. Tack för idag.